Right, hey everyone. We're going to get started in Chapter 5. 5.1 is on the mid-segment theorem and the coordinate proof. And actually, we're really going to just focus on the mid-segment theorem today. So what is a mid-segment and what are properties of mid-segments? So a mid-segment of a triangle is a segment that connects the midpoints, hence the name mid-segment. And a coordinate proof is a proof that involves placing geometric figures in a coordinate plane. So mid-segment theorem. It is the segment that joins the midpoints of two sides of a triangle. Okay, and then the first property is that the mid-segment is parallel to the third side, and it is half as long as the third side of a triangle. Okay, and before I get too far ahead of myself, I do realize that I changed this note sheet from you. The note sheet you have is probably a little bit different. It was a little bit more wordy and condensed, so I actually changed this to be a little more user-friendly. So you don't have this, I apologize, but you can write this stuff down on a separate sheet of paper, like a notebook paper or printer paper. Again, I apologize. The problems are actually going to be a little bit different too, so you will need a separate sheet of paper for this. So mid-segment is parallel to the third side, and it's half as long as the third side as well. So if you look at this first example, the first picture, it says if we are given that W is the midpoint of TK, so W is the midpoint, and C is the midpoint of KN, so notice that WC connects the midpoints. So what can we say about this then? Well, we can say that we know KW is equal to WT and KC is equal to CN. Right, and I actually already marked that on here. I should put 2 marks over here. So it would look like this. Okay, so see the marks. We got, I'm going to change this to blue marks over here. So we got red marks on the left, blue marks on the right. Okay, that just shows that they are midpoints. And the 2 parts of each side are going to be equal to each other. Okay, the next part is we know that segment WC is parallel to segment TN. So we would say these 2 lines are parallel to each other based on the definition of the theorem of mid-segment. That comes from up here. So WC is parallel to segment TN. We also know that WC is equal to 1/2 of TN. So WC equals 1/2 of TN. I'm going to put a little or here. Or we could say 2 times WC is equal to TN. So basically, the bigger segment is twice as big as the smaller one. So hypothetically, if TN were 10, WC would be 5. Likewise, if TN were 12, WC would be 6. Okay, it's half as big as the third side. Okay, so a quick example. They tell us P, Q, and R are midpoints. So if P is a midpoint, that means these 2 parts are equal. If Q is a midpoint, that means those 2 parts are equal. And if R is a midpoint, then DR is equal to RF. Okay, and they tell us that DE is 18. Okay, so let me do this. So this whole side is 18. EF, so this whole side over here is 15. And DF, so this whole side is 12. Okay, and that came from right here. Okay, so let's take a look. If DF, so if this side is 12, and look at PQ. PQ is a mid-segment because it connects two midpoints. So if DF is 12, how big is PQ? PQ is clearly smaller, and in this case, PQ is equal to 6, because PQ is 1/2 of DF. So 1/2 of 12 is 6. Changing colors. Go to yellow. We want to find out how big is QR. So QR is right here in yellow. So QR is parallel to, those two yellow lines are parallel. So if DE is 18, how big is QR? It's 9, because QR is equal to 1/2 of DE. Okay, so those mid segments are half as big. And just to fill in other things around here, if you look at DE on the top, these two will both be 9 because they're half as big as 18, because P is a midpoint. Okay, and over here, these would each be 7.5 because they're half of 15. And over here, those would each be 6 because it's half of 12. Okay, so we can really find out all these parts. And again, we said PQ is 6, and we said QR is 9. Okay, just grab my highlighter. So you can see we have 9, 9, and 9. And we have 6, 6, and 6. And that's what it's going to look like when you do mid-segments. Okay, checkpoint 1. Find the missing variables in the picture. So if you look at the picture, B is a midpoint, and so is D. So this segment, B to D, will be called a mid-segment because it connects the midpoints. So we know that BD is equal to 1/2 of AE. So that means Y is equal to 1/2 of 30. So what is half of 30? 15. So Y would be 15. Okay, and then over here to find X, if you look at the picture, since B is a midpoint, X would have to be 12. Because the midpoint means it cuts in half, and each side would both be 12. Okay, and we have checkpoint 2. Checkpoint 2 says solve for the variables in the picture. We got to find out what is M. So notice these marks show that G is a midpoint, and the marks down here would show that I is a midpoint. And that means that that blue line, GI, is a mid-segment. And again, mid-segments are half as big as the third side. So that means GI is equal to half as big as FJ. So GI is 7. So 7 equals 1/2 times 2m minus 8. So we want to solve this to make these equal to each other. See, then we'll go with red now. To make this equal to the bigger side, you would have to double it. So we're actually going to go times 2 on both sides. Because times 2 will cancel out the 1/2. So 2 times 7 is 14. 14 equals 2m minus 8. Another way to think of this, if the mid-segment is 7, that means that this green segment is going to be twice as big. So that green segment would have to equal 14. So again, 14 equals 2m minus 8. And then we solve it. Add 8. And we get 22 equals 2m. and then divide by 2. So 11 equals m. All right, and that's what we got for mid-segments. That's all we're going to cover for today. Again, I apologize that the note sheet is different. I changed it. I totally forgot that you don't have the modified version, but again, you can just jot these problems down on a separate sheet of paper to help yourself out. And the homework is very similar to these couple problems.